Good morning, good afternoon, good evening, wherever you may be. Thank you for joining us for Build 2020. And thanks for joining us for this session entitled Building Mixed Reality Applications with Azure. My name is Matt Fleckenstein. I run marketing for our mixed reality group here at Microsoft, and I'm going to be co-presenting with a colleague of mine, Tyler Adams. Tyler, you want to say hello and maybe introduce yourself?
Hey, I'm Tyler Adams. I'm the lead program manager on the Mixed Reality Developer Platform team.
Awesome. So I'm going to kick things off and give a little bit of an overview of what mixed reality is and how we got here. And then Tyler's going to come in and talk about some of the exciting things we're doing to make mixed reality development easier by leveraging some of the tools offered through Azure. So let's go ahead and jump in. I think we can all agree that cloud computing is arguably the biggest secular trend in computing over the last decade. It's fundamentally changed the way that we build, manage, and deploy applications. And probably even more important than that, it's really enabled every company to become a technology company. And while the cloud has gotten us most of the way there, it's not without its limitations, in particular when we think about the basic laws of physics. As we get more and more devices out into the world, we have billions of connected devices and billions of connected people. There's an important need for ultra low latency computing that is embedded and imbued with mixed reality and AI to light up the next generation experiences. Perhaps the best example of this is what we're seeing today in this fourth wave of computing, where mixed reality is really enabling ubiquitous computing at the edge that blends the physical and the digital worlds. If you go back to the 1970s, really when the computing era started, business users had access to compute power for the very first time through mainframes, but they were literally tethered to their desks. In the 1990s, we saw the rise of personal computers, which extended computing power into our homes, and eventually through laptops gave us some level of compute power on the go. But it wasn't really until the 2000s, when smartphones became ubiquitous around the world, that we had the power of a computer in our pocket that we could literally take with us anywhere. And we started to get some notion of the power of contextual awareness in computing, things such as our location in time and space. But with mixed reality, we're taking that to an entirely different level. And this kind of blending of the digital and physical world opens up a whole new set of opportunities. And those opportunities, while exciting, are not without their challenges. I like to kind of refer to this great quote from a good friend of mine from a portfolio company of ours called Azure, called Spatial. He talks about these challenges that really they're facing, and all of us are facing when we're trying to connect the digital and the physical worlds. And as we talk about it, he often comes forward and says, hey, this is not for the faint of heart. And while we agree that there's still certainly challenges to overcome in terms of creating this seamless blend and these incredible immersive experiences, there's a lot that we have going on here at Microsoft to try to make that easier for developers such as yourself. And so with that, I'll actually turn it back over to Tyler, who's going to come in and talk about some of the exciting stuff that we have that will make developing these immersive mixed reality applications much easier for you. Tyler?
Thanks, Matt. Yeah, and as Matt mentioned, there's a lot of challenges in merging the digital and the physical world. And I'm really excited to share today a lot of the work that we have done to help developers address those challenges. It starts with our Mixed Reality Toolkit, which is a set of components that helps accelerate your development. That toolkit is available in world-leading 3D creation engines, Unity and Unreal. I'm then going to show how you can easily add Azure to these applications to increase the power of these applications you're creating. So let's start with a brief overview of the Mixed Reality Toolkit. The Mixed Reality Toolkit, as I mentioned, has a set of components that helps accelerate your development. One of the challenges that developers may face in building mixed reality applications and merging the digital and the physical world is how do you take the powerful capabilities of HoloLens, hand tracking and eye tracking and voice, and enable users to easily manipulate holograms with confidence in a world where there's no haptic physical feedback. And so MRTK has done a lot of work to help make that easy for you. So let's jump in. A great place to get started with MRTK is our sample scenes. These scenes let you explore what's available in the toolkit and envision the different types of things you can create with it. All of these different components are highly customizable, so you can tailor them to your experience. An example I give is the keyboard that you can see there, which is a customized version of our button. And as I mentioned, these are based on years of iteration to help make it as easy as possible to leverage the full power of HoloLens to easily interact with holograms with confidence. And so you can see some of the visual effects that help show you that your hands are in proximity and that you've grabbed these objects. I'm also going to show how to easily leverage Azure in these applications to increase the power of those applications. There's two Azure services that I'm excited to talk about. One is Azure Remote Rendering, which is in private preview. Azure Remote Rendering enables you to render high detailed content on Azure and stream it down to the device. So you could imagine construction scenarios, for example, where you might have a lot of different information in detail, and that detail is really important to your scenario. And Azure Remote Rendering enables you to render that detail. The other service I'm going to talk about is Azure Spatial Anchors. That's in general availability today. That enables you to store and persist the location of holograms in the real world, so you can share that across users and across devices to create multi-user experiences where all the users can see the holograms in the same place.
Awesome, Tyler. Hey, I'm a big fan of actually all of the different components that are available in the MRTK toolkit. And of course, I love seeing our mixed reality services that really leverage the power of both the edge computing capabilities on a device like a HoloLens or your mobile phone, as well as the power of Azure, right, the cloud. But let's talk a little bit more about how you can use these building blocks in creating real world 3D content and immersive experiences. Why don't you tell us a little bit more about what you can do with these capabilities in the 3D content tools that exist out there?
For sure. And that's a great segue, Matt. So as I mentioned, these components and services are available in world-leading 3D authoring tools, Unity being one of them. So let's jump in and show how to easily leverage these capabilities inside a Unity project. So here I have an existing Unity project that already has the mixed reality toolkit installed. And it has the Azure Service plugins installed as well. So I'm going to go ahead and search for the object manipulator script, which is part of MRTK, and just drag it on this hologram. This script enables the hologram to be movable, rotatable, and resizable with one or two hands. I'm then going to drag on the near interaction grabbable script that enables you to have those interactions close up to the hologram. So we're going to go ahead and hit play. MRTK enables you to simulate input without a headset. So inside the Unity editor, you can validate these interactions that you've just created. And so we'll go ahead and use input simulation to move the hologram around, rotate it, and test out these different interactions. You can then go and find the perfect place for this hologram. And if we wanted to persist that location so we could share it across users and devices, we could add an Azure Spatial Anchor. So we'll go ahead and search for the Azure Spatial Anchor Manager and drag that into our project. This enables you to configure Azure, so you can set up your account ID and key. We'll then go add the anchor module script, and this is the script that you'll use to create the anchors. And so to create the anchor, what we'll do is we'll just add an MRTK button to the scene, search for a pressable button, and we'll go ahead and drag that into our scene. I'll then zoom out so you can see it. There it is. So we'll go ahead and select the button, and we'll just change the text to say create anchor. And then let me show you how easy it is to set this up. We'll just go ahead and select the pressable button and scroll down to its onPressable event. That event is triggered when articulated hands press the button. And so we can go ahead and drag the linear module into this, which has the Azure Spatial Anchor script on it, and then just go ahead and create an Azure Anchor. We're also going to do the same thing to the onClick event. The onClick event is triggered by additional input sources. So it's triggered by voice and eye tracking. And so it's just that simple. Just drag in the object and select Create Azure Anchor. Now I should highlight that there's actually 3 steps to create an Azure Spatial Anchor. You'll want to start an Azure session, create the anchor, and then end the session. I just showed you the second step, creating the anchor. The other 2 steps are as easy to set up.
Awesome. That's exciting stuff. I love actually how you can, you set this up very easily to leverage Azure Spatial Anchors to take advantage of both, your own hand motions as well as, sight and voice, which is awesome to see. Hey, I know I have a lot of gamer friends who, many of which actually do some development in Unity. Many of them also, use Unreal. Why don't you tell us a little bit about kind of how you can do similar things and take advantage of these MR services in an engine like Unreal?
Definitely. So actually, I'm really excited to announce that Unreal just shipped Unreal Engine 4.25, which includes production-ready support for HoloLens development, support for Azure Spatial Anchors. And alongside Unreal 4.25, we just shipped the initial preview of MRTK in Unreal. So let's dive in and take a look at what that looks like. First, I should highlight that in Unreal, you can build applications using C++. You can also build applications using Unreal's Blueprints, which is a visual scripting language that lets you create logic without writing any code. And that's what I'm going to show you today. So here's an existing project for a chessboard. I'm just going to go ahead and hit play, and you can see we support the same input simulation in Unreal that we support in Unity to enable you to validate interactions without a headset. So as I mentioned, we support Unreal Blueprints. So we'll go ahead and create a Blueprints class, and we'll subclass that simple button, which is an MRTK button. So we'll go ahead and create that. And I'm going to rename the button for the purpose of this demo, Reset Position. We can then go select the button. It's a little far out. Let's zoom in. There we go. And now you can see what the button looks like. So what I'm going to do is in the components window, I'm going to select the button. And then on the right-hand side, we can go ahead and add a button pressed event. So let's go ahead and add that there. And that'll add a button pressed event node to our visual script. I'm then going to create a variable in the visual script and connect it to a chess piece. And that enables the script to access that chess piece. And so we'll just connect it to an existing chess piece that's on the board. And I'll go ahead and drag that variable into the script so that we can reference it in the script. The chess piece has a function on it, reset position, that's already created. So I'll just drag that out and add the reset location node to the script. And then it's super easy. Just drag on button press to reset location to have the button trigger that function. I'll drag the button into our scene and then just set the location and size of it so we can see it. Let's scale it up a little bit. Set its position so we can see it. There we go. And now I'm going to go ahead and hit play. And then we can use input simulation again to validate what we've just set up. So we'll go ahead and grab the chess piece and move it to a new spot, and then press the button to reset its location using the visual script that the blueprint script that we just set up. And now, if this was a multi-user experience that we were creating, we'd want to be able to store that chessboard's location in the real world so that multiple users could see it in exactly the same location. And we'll go ahead and use an Azure Spatial Anchor for that. In Unreal, local anchors are called AR pins. That enables you to pin a hologram to a location in the world, but only for a single user on a single device. We'll go ahead and store that up on Azure with an Azure Spatial Anchor so we can then share it across users and devices so all the users can see the chessboard in the same location. We have documentation online on how to create AR pins. I'm not going to go into that today. I'm going to go into how to convert those to an Azure Spatial Anchor and store them on the cloud. So let's go back to the same project. And I'm going to open up the blueprint for the chessboard. And when this blueprint starts on begin play, I'm going to create an Azure session. And then let's go add a node to configure that session where we can add our account ID and account key. So you just go ahead and add in the Azure ID and account key that you can get from Azure when you set up your account. And so now let's go create an AR pin. Oh, actually, let's start the session. Sorry. Yeah, we'll start the session. And now we'll create the AR pin. Starting the session collects the data required to create the pin. And so we'll create a pin, and then we'll set that pin's location to the root of the chessboard. So we'll go ahead and grab the chessboard's root, and we'll grab the transform of that root just to grab its location in the scene. There it is. And then we'll connect that to create named AR pin. And so that creates a pin at the location of the chessboard. We'll then connect the chessboard to that anchor. So now the chessboard is now anchored to that location. And then finally, we'll save it up to the cloud to save it as an Azure Spatial Anchor, which we can then recall later or share across users. And there you have it. It's that simple in Unreal Engine to leverage Azure Spatial Anchors in order to store the location of holograms and share them across users. So that's really a high-level overview of how we've helped provide tools to address some of the challenges of mixing the digital and the physical world with components through MRTK that are available through world-leading game engines, Unity and Unreal, and how you can easily add Azure to those applications in order to increase the power of those apps. For more details, go to docs.microsoft.com, mixed reality development.
Hey, thanks a lot, Tyler. Hey, do me a favor. Go back to that last slide for 1 second. We're getting a lot of questions as to where people can kind of go and get these tools and how to access them. And so I'm just going to emphasize it again. It's all about docs.microsoft.com/mixed reality development, right? So go check it out. Would love for you guys to do that. I do have a bunch of questions, and looking at time, it seems like we've got some time for a few of them. So let's just kind of pick a few of these and basically, okay, first question, where can we get these plugins at? Guess where you can get them at? docs.microsoft.com/mixed reality development. So go check it out. Would love for you to do that. There's a question here on MRTK specifically. Looks like it's maybe from somebody familiar with HoloLens 1. Can you talk about some of the biggest differences between MRTK for HoloLens 2 versus for HoloLens 1?
Yeah, some of the biggest differences is really embracing the new capabilities of HoloLens 2. So providing components that enable you to fully leverage fully articulated hand tracking and eye tracking to enable you to build experiences where you can leverage those capabilities to interact with holograms with confidence.
Awesome. Hey, I see a question here about does this work for mobile devices? And it goes on to talk about spatial anchors, right? And so, there's also another question here in terms of, can you leverage any of these tools for VR? So maybe you want to just talk about kind of the cross-platform story a little bit, and then we can get into a few more specifics based on some other questions folks have.
Yeah, absolutely. So Azure Spatial Anchors is available on mobile in addition to HoloLens, supporting iOS and Android. So that's absolutely available to you. And the Mixed Reality Toolkit is also available cross-platform and includes VR and AR support.
Awesome. And again, I think if you would actually, if you're interested in VR development, there's some other tools that are out there as well. Like Maquette is a nice prototyping tool that we have. And so again, just refer you back to that same location, docs.microsoft.com, to kind of go learn more. So are the Azure plugins compatible with the latest Unity editor, 2019.3, or do we need to install a preview? And I'm not sure exactly what they mean by plugins, but let's just assume they're talking about kind of the whole thing here, right? The toolkit components, as well as maybe the ability to use spatial anchors like you demonstrated.
The answer is yes. Azure Spatial Anchors is available in Unity 2019.3. And I'm assuming they're referring to the manager scripts that we have that help you set that up. And yes, those are available to that.
Awesome. Cool. So another quick question here, which is, specifically, do spatial anchors hold when the lens is occluded?
So the spatial anchors themselves are actually stored up in the cloud and persistent. So once you store it, the spatial anchors hold. Now, if the lens is occluded in some way, it's possible that it might impact your tracking and it could impact hologram stability, but the anchor itself will be stored and persisted.
And then the moment they're unoccluded, I assume kind of you're back to normal and being able to kind of locate where you are and find them as normal. Is that right, Tyler?
Of course, yeah.
Awesome, cool. Hey, there's a question here in terms of just talking a little bit about the Unreal and Unity, and in particular, any kind of vision or any kind of foresight into maybe some future stuff that we will have going on with them. I know we're limited in terms of what we can talk about, but lots of interest in particular around any plans we have for Unreal 5, right, which has been announced.
Yeah. So, I mean, as you mentioned on both sides, there's only so much I can share. We're certainly absolutely in planning conversations with both Unity and Unreal to envision the future. Unity did just ship AR Foundation support for HoloLens 2, which enables you to use the same code that you'd use to write a mobile AR apps to also write HoloLens apps. And MRTK has shipped experimental support for that. So we're absolutely working with Unity to provide great support for their out-of-the-box AR development story. In terms of Unreal 5, a very exciting announcement that they just announced, and we're very excited about all the new features that are coming there. But we're pretty early in conversations with them, and so nothing to disclose yet. Stay tuned.
Awesome. Hey, Tyler, I've got a question here. Can you also target Oculus, right? Oculus devices. I'm not sure necessarily the context of that, But you want to talk a little bit about, again, kind of, I think, our story as it relates to VR and devices like Oculus as well.
Yeah, so this is actually a very common request, particularly for MRTK, to make our components available to Oculus developers. And what I can say is it's a request that we take very seriously, and we're looking into it. So also stay tuned.
Got it. So I've got a question here. What is the roadmap of Azure Spatial Anchors, and when will it support Unity 2019.3?
Oh, it supports that now.
Yeah, and so in terms of the roadmap, look, I don't think we're ready to disclose any specific things on the roadmap, but as Tyler said, you've got that support now. It just as of today actually was now generally available, so anyone can go and get it on Azure.com. The other thing I'll say is this whole area around being able to kind of persist and share 3D content in space is certainly a hot area. And I think, without going into details of specifically the types of things that we'll be releasing in the future, we do talk a lot about the need for us to continue to build out a spatial services portfolio. And so really building on top of the work that we have with spatial anchors, you can imagine us doing things to make it easier for developers to take advantage of things like wayfinding and navigation in those applications, or a lot of this has to do with understanding when you're using spatial anchors, the scene in which the anchor is being kind of persisted, which gives you an ability to kind of create a digital twin of a space. And there's some other sessions out there at Build around digital twins. And so that may also be something where, I think you'll increasingly see investments from us in terms of making it easier for you as a developer to reconstruct spaces and leverage that map for all kinds of different scenarios. So just kind of stay tuned on that. Lots of exciting stuff coming up in the not too distant future. Is there a way to search the tools from MRTK like Button faster? Like, how do they find kind of those tools? Is there an easy way for them to easily identify different tools available in MRTK?
Yeah, and so as I showed in the demo, if you know the tool you're looking for, you can just search for it in the Unity editor and find them. However, a great way to explore what's available is actually the sample scenes, which sort of shows you a breadth of different features that are available in MRTK, and can help you discover those. Those sample scenes are also open source, so you can go and look at the code, see what's available, see how things are set up, and leverage that in your own way.
Awesome. Hey, here's one, Tyler, about Azure. Again, another question about Azure Spatial Anchors. This one has to do with what are the big differences between Azure Spatial Anchors on mobile devices versus on a HoloLens device. I can take that one to start with, and feel free to weigh in.
Yeah.
I think, look, essentially it's the same APIs. We're using the same Azure service to enable these kind of cross-platform experiences. There are some minor differences in terms of some of the results and performance you'll get just based off of the device you're using. When you've got something as robust as a HoloLens that you're leveraging, you have a tremendous amount of data points around exactly the scene around you and exactly where you are in time and space. And so oftentimes accuracy can be higher perhaps than on a mobile device. And so, again, it's the same set of services. We've tried to kind of make it easy to basically build your application once and then really run it cross-platform. Again, depending on the device, you may see a little bit of kind of differences in terms of performance due to just the native platform that you're building on. But overall, really committed to kind of making it easy to do this cross-platform. Here, I've got a good one. I want to trigger an audio when inside a proximity to an anchor. Are there proximity functions?
Yeah, so inside both the 3D engines, you can easily set that up using the tools that they provide. So you can detect both the location of your hands and the location of your head, and you can use that to sort of trigger proximity. So an example I might give is in Unity, you could put a collider, which is an object around an object that you wanted to trigger. And as something entered that collider, you could then trigger something like audio to light up.
Got it. Here's a good one. So now that Azure Spatial Anchors is entering general availability, will it continue to be free? So look, I'll take this one. If you go to Azure.com and you visit the Azure Spatial Anchors page, it's been updated with a pricing tag. And if you click on that pricing tab, what you'll see is pricing. We plan to announce pricing in the coming weeks, and we'll actually start pricing for Azure Spatial Anchors on August 1st is when pricing will actually kick in. And so you've got a little bit of time to go out and continue to kind of use it for free. While we're not disclosing pricing at this time, I will say that, we've tried to price this thing in a way where, basically you've got a certain level of usage for free. And then when you actually get into higher volumes of usage, you do have to pay for the service, but try to price it at a relatively kind of low cost point, because the goal here is really to get as many people adopting this as possible. So look for more on pricing. Know that it will be coming August 1st, but as of right now, it's still free. So would encourage you to go check it out. Any plans for WebXR, Tyler? There's a
Oh,
big hairy one, yeah.
yeah. We're absolutely deeply engaged in the WebXR community to help move forward that open standard to support mixed reality development. So lots of plans underway. And in fact, coming up later this week, there's several sessions at Mixed Reality Dev Days that cover some of our investments in the WebXR space. Highly encourage folks to go check that out.
So hey, I see a question here from John, right? That's basically asking, hey, can we download anchors for times when the internet is not available? And maybe even just take that up a level and say, hey, how do you leverage things like spatial anchors when Wi-Fi is spotty or those types of things?
Yeah, so a spatial anchor is really just converting a local anchor so that you can store it up on the cloud. But that local anchor is still there. Once you get the anchor, you then set it as a local anchor. So you can absolutely store that locally and recall it. But to share it across users and to share it across devices, you'll want that connectivity.
Got it. So here's one similar kind of path, right? This one comes from Torin. Can temporary, and temporary is in quotes, Azure spatial anchors be used in Unity, be stored locally rather than in Azure? Or is there an alternative for local shared space multi-user content that doesn't need to persist after the session? And so maybe, I think you can kind of go back to kind of what the example you used with AR pin, but I think this one is specifically for Unity, right? And, how do you think about kind of using stuff locally that you don't need to persist?
Yeah, so in Unity, we support local anchors as well. If you were to create a multi-user experience, you would want some way to share that across users, and Azure Spatial Anchors is a way to do that. You can also set the timeline that is stored up on Azure, and so that is configurable.
Yeah, and I think by timeline, what I think Tyler's talking about is there are some controls with spatial anchors in terms of how long you want those anchors to persist. You've also got the ability to, control who has, the ability to kind of access those anchors as well, based on tenant ID or whatever for some of our enterprise customers. And it looks like we've got time for maybe just a couple more here. Can MRTK support and unify development of AR Core and AR Kit, like the Xamarin for mixed reality?
So MRTK itself is built on top of cross-platform abstractions. So for example, in Unity, as they just announced AR Foundation support for HoloLens, which is one common API that enables you to build experiences that can run on iOS, on Android, and on HoloLens. MRTK is experimental today and available in an experimental way, built on top of that so that you can leverage MRTK in these cross-device scenarios.
So here's one more, Tyler. Kind of coming back to basically guidance. Relatively new to this space. How would you encourage somebody to kind of get started with all of this?
Yeah, so I mean, call out again to our mixed reality docs online. There's lots of great getting started tutorials there. So effectively, I would go in, pick your path, Unity or Unreal, or try both. And then there's some great getting started tutorials that can help you get set up. The other thing that I showed earlier was the MRTK sample scenes, which is a great way to explore what's available in the toolkit and to envision the types of things that you can build with it.
Got it. Hey, Tyler, lots of nice kind of comments on your presentation and what you went through. I do have a couple of requests for your contact information. I'm not sure if you've got a Twitter handle or something that you can share with folks, or if that's possible, but if so, you want to throw that out there?
I don't have one that I want to necessarily share immediately, but one thing I will encourage folks to do, we're very proactive in engaging with the community. And actually, Mixed Reality Toolkit is up on GitHub. So please file feedback and questions there. And myself and my team will absolutely get back in touch with you and stay engaged.
Awesome. Hey, I think we're just about at time. Any kind of parting thoughts for folks before we kind of wrap up this session, Tyler?
My biggest thing is I'm just super excited to see what people build with these tools and what you create with them, and also highly encourage engagement in the community. So as I mentioned before, feel free to jump in on GitHub and provide feedback and help us make these tools even better than they are today.
Awesome. Hey, what just in kind of closing here, a lot of questions about Azure Spatial Anchors. I'm turning right around and moderating a session there, and so if you want to kind of watch that, feel free to check it out. Thank you very much.
Thanks, everyone.